Shale oil production through hydraulic fracturing or fracking has seen a tremendous growth over the last decade, with a cumulative annual growth rate of over 35%. However, this is just the tip of the iceberg, as new exploration techniques are discovering more and more shale oil resources. Shale oil production and fracking are here to stay. However, the industry faces a major challenge in water usage, management, and disposal. We can understand these challenges using a simplified two-step model. First, fresh water is pumped into the well to force the natural gas out of the rock formations. This water then comes back to the surface in a heavily contaminated state. This is referred to as flowback or produced water depending on its time of release. This leads to three major issues. First, the well needs a large amount of fresh water to get started. Second, disposing the untreated flowback water locally by using wells or pits is very dangerous to the environment. Third, there are high transportation costs associated with disposal of this water. Dealing with flowback water is a major problem and thus a huge opportunity. So far, three different approaches have been used for managing the flowback water. First, disposing untreated water on site or off site. However, this runs into environmental and regulatory concerns. Second, transporting water to treatment plants and back for reuse. However, the transportation costs are prohibitive. Moreover, recent studies have shown residual radioactive contamination in the treated water. Third, the best solution. It appears to be treating the water locally and reusing it. However, the current methods have been largely unviable due to having both high setup costs and high variable costs due to their energy intensive nature. Moreover, there is a large variability in types and level of contamination, and the existing solutions are not geared towards this problem. The industry needs a one stop, local, and low cost solution.
What we are claiming here is that graphene and its functionalized forms can be the answer to these industry needs for the following reasons. First, graphene and derivatives have been demonstrated to treat most of the well-known contaminants in flowback waters. The list includes metals like copper, lead, and mercury, radionuclides, and more complex pollutants like organic compounds. In almost all cases, the simple addition of the suitable graphenic compound will lead to the isolation of the pollutant and allow for an easy removal. Second, the simplicity of the involved processes and of the needed infrastructure makes the local treatment option viable. One indeed just needs the raw graphenic material and suitable tanks where to operate the treatment. Finally, the intrinsic properties of graphene, and in particular its large active surface area, give rise to very effective decontaminating processes. Together with the semi-spontaneous nature of the involved reactions, this generates a significant gain in operational costs, especially when compared with other currently adopted techniques, which are considerably more energy intensive.
GreenFrog business idea will require approximately $50 million and around 6 to 7 years to reach profitability. We divided the development in 4 different phases. The first step will be the research phase, during which the team will perform literature and lab research to identify and synthesize all the relevant functionalized graphene oxide compounds required. This phase will last around 18 months and will require between $1 and $3 million. The team will be expanded to include research associated with lab experience. The second step will be the pilot phase, during which the team will design, build, and operate a small-scale treatment plant. The scope is to validate the technology before scaling up to industrial phase. This phase will last approximately 18 months, will require between $5 and $10 million depending on capex. The team will be expanded to include experienced design engineers. The third step will be the go-to-market phase, during which the team will partner with an incumbent player and will design, build, and operate the first industrial-scale treatment plant. The scope is to prove the technology at industrial scale and validate the royalty business model. This phase will last approximately 18 months, will require